Quideo 5 Advanced. If there is no seasonal effect on human births, we would expect equal numbers of children to be born in each season, winter, spring, summer, and fall. A student takes a census of her statistics class and finds that of the 120 students in the class, 25 were born in the winter, 35 in the spring, 32 in the summer, and 28 in the fall. She wonders if the excess in the spring is an indication that the births are not uniform throughout the year. The first question asks, what are the null and alternative hypotheses associated with this question? To answer that, they would be that the null hypothesis is that there is no association between the season and how many children are born, and the alternative is that there is an association between the seasons and how many children are born. The second part asks for us to compute the chi-squared statistic. To find this, we will use x squared equals the sum of the observed value minus the expected value squared divided by the expected value again. After some easy inputting of the equation, you come out with a number that would be 1.933, and that would be your chi-squared statistic. Next, the question asks, how many degrees of freedom does this chi-squared have? Well, since there are 4 samples, you just do n minus 1 equals your degrees of freedom. So, we know that our 4 is our n, so we just do 4 minus 1, making our degrees of freedom equal 1. Not 1, I apologize. Degrees of freedom would be 3, definitely. The final question asks, what can you conclude about the null hypothesis at alpha value of 0.05? At this, we'd say, at an alpha value of 0.05, we would fail to reject the or the null hypothesis, that there is no association between the season and how many children are born, based on our p-value that we know will be greater than 0.25.